Hey guys, welcome back to another video lesson with Mr. Tran. Today we are doing 11.7, the second part. So we're talking about the relationship between the ratio of the sides to the ratio of the areas of similar figures. Let's go. Sway. So let's do a quick review on what we did last time for 11.7 part 1. Okay, so last time we were talking about figures that are not similar, so the ratio of their sides are not consistent. So the first one we're looking at here is we have a rectangle that's 4 by 5 and we're comparing that to one that is 12 by 10. You take the ratio of the width, that is 4 to 12, and you simplify that, that's 1 to 3, and you take the ratio of the length, which is 5 to 10, and simplifying that gives you 1 to 2. Now if you want the ratio of the area, you just take the ratio of the length multiplies by the ratio of the width. So that gives you 1/3, or 1 to 3, times 1 to 2 gives you 1 to 6. So the ratio of the areas is 1 to 6. Okay, so the general formula that we developed last time should be the ratio of the areas, which is A1 to A2, is equal to the ratio of the width, which is W1 over W2, times the ratio of the length. Okay, so that will apply to all types of shapes that are of the similar type. Okay, so rectangles to rectangles, triangles to triangles, and so on. So moving on to today's lesson, we're talking about comparing the ratio of the areas of similar figures. Okay, so the key here is that if you guys recall, similar figures have ratios of sides that are consistent. Okay, so if one pair of corresponding sides have ratio of 1 to 5, then all the other pairs of corresponding sides have the same ratio. Okay, so let's look at the first example here. I have two triangles, and we know that they are similar, and that the corresponding sides AC and DF are 8 to 16. Okay, so the ratio of the sides AC to DF is 1 to 2. Now, based on that, I know that the ratio of the bases CB to FE is also 1 to 2, and the ratio of these professionally drawn heights are also 1 to 2. Now, based on that, I can find the ratio of the areas, right? Because the ratio of the areas of the triangles is equal to the ratio of the bases times the ratio of the heights. So you just take those two and you multiply them together, you get the ratio of the areas. So the ratio of the areas of figure 1 to figure 2 is equal to 1/2 times 1/2, which is 1/4. Okay, now in this case, we can't find the areas of these triangles because we only know one of the sides. We don't know the base, we don't know the height, so we can't find the areas, but at least we know that the larger one is 4 times the little one. Okay, so in this example, we are going to look at how to use the properties that we just discovered to solve these problems. Okay, so here you have two triangles that are similar, and you know this side here, this base is 4, CB is 4, and this base here is 12. And they tell you that the area of figure 2, DEF, is 90, and they want you to find the height of the little triangle. Now, there are a couple ways to do this, okay? But you have to know that the ratio of this CB, so CB, whoops, CB to FE, because there's corresponding, you can use that ratio. It's 4 to 12, which is 1/3. And that will apply to the height, okay? But since the ratio of the base is 1/3, the ratio of the area, okay, so area of figure 1 to area of figure 2 is actually base 1 over base 2 times height 1 over height 2. Now, because base 1 over base 2 is 1/3, and we know that they're similar, so the height 1 and height 2 also has the same ratio, so that's also 1/3. So the ratio of the areas, that ratio is equal to 1 to 9. Now we can use that ratio, okay? So 1 to 9 is the ratio of the large area to the small area. So the large area is 90, and the small area, we're just looking for that. So we can just say that's x. And so that gives you, I want to say x is equal to 10. Okay, so this area is the area of that triangle. Now from there, we can find the area, I mean the height, by using, from there we can use the formula of the area of a triangle to find the height. So area is equal to 1/2 base 1 times height 1. And area 1 is 10, so I have 1/2 times the base is 4 times the height. That's 1/2. So that gives you, I can cancel that. That becomes 2. Height is equal to 10. So my height, or height 1, is equal to 5. So that gives you 5 as a height. So you can check that by multiplying this out. 4 times 5 is 20. Half of that is 10. This is 90. So it works out. So 1 to 9 is 10 to 90. Okay, another way you can do that is you could have, using the area is 90, to use that and find this height right here, height 2. And once you find that height 2, then you can use the ratio of 1 to 2 and find that, right? So I can show you that real quick right now. So area 2 is 90, and that is equal to 1/2 times the base. So I'm using 90 for this triangle. The base is 12 times that height 2. And that gives you 6 times height 2, whoops, times height 2. So height 2 comes out to be 15. And since the ratio of the bases is 1 to 3, the ratio of the height is also 1 to 3. So this gives you also height 1 is 5. So to summarize all that up, we put this into a theorem. So if you have two similar figures, the ratio of their areas is equal to the square of the ratio of their corresponding sides. Okay, so you only need one pair of corresponding sides to find the ratio of the areas. And it also works for triangles where you don't know the sides but you know the heights. You can also do that. So the ratio of the areas is also equal to the ratio of the heights squared. We call this theorem the similar figures theorem. So we have another theorem that's kind of thrown into this section, and it deals with triangles. Okay, so when your triangle gets bisected, or if there's a median drawn in your triangle, so here we have that median there. Okay, and so what we know about the median is that it cuts the side that is drawn to into two congruent segments. So you see how the base now of that triangle is cut into two congruent segments. Then what we can see is here, if we kind of split the triangle into two different triangles, and then we draw the height or the altitude of these triangles. So the height, they are actually the same measure. Okay, so the height is from that same triangle. So the height are equal to each other. And you see the base, since the bases are equal and the heights are equal, the area of these two triangles are congruent. So we have a theorem that says the median of a triangle divides the triangle into two triangles with equal areas. Okay, so remember, this goes in your pink sheet, right? So write this down, and it's going to be part of the things that we need to know for this year. Again, the median divides the triangle into two equal parts. The areas are equal. Okay.